Good afternoon. Today we are going to discuss a 12th standard chapter, electrostatics. എന്ന് പറഞ്ഞാൽ ഇലക്ട്രിക് ഫീൽഡ്, പൊട്ടൻഷ്യൽ, ഡൈപോൾ, കപ്പാസിറ്റൻസ്, ഇങ്ങനെ 4 കുഞ്ഞ് യൂണിറ്റ്സ് ഇൻക്ലൂഡ് ചെയ്തിട്ടുള്ള ഒരു ഹ്യൂജ് ടോപ്പിക് ഇലക്ട്രോസ്റ്റാറ്റിക്സ് എന്നുള്ള 25 ക്വസ്റ്റ്യൻസ് ആണ്. ഹൈലി പ്രോബ്ലമാറ്റിക് സെക്ഷനാണ് കമ്പയർഡ് ടു ലാസ്റ്റ് സെക്ഷൻസ്. അപ്പം അതുകൊണ്ട് കുറച്ച് ശ്രദ്ധയോടെ discussion attend cheyanam oru request. Okay, let us start the first question. The first question is about the ratio of the surface charge densities. First I will explain the meaning of surface charge density. Charge per existing area, charge per unit area, that's the definition. Charge divided by existing area. Here two charged spheres, radii are given 10 cm and 30 cm, are connected or brought in contact electrically. Then what happens? Charge flows from one to the other until the potential is equalized. Here the question is about the ratio of the surface charge density. Okay, I will give the meaning of surface charge density. Sigma, surface charge density sigma equal to charge divided by existing area. For spheres, it becomes charge divided by 4 pi r square. Surface charge density. Now, when two spheres are given, radii 10 cm and 30 cm. Now, the ratio of surface charge densities. If two charged bodies are connected by a conducting material, or if the two bodies are brought in contact electrically, the charge flows from one to the other until the potential is equalized. This concept is utilized for this problem. Okay, let us have a look about the problem. Sigma 1 by sigma 2, ratio of surface charge density. Q1 divided by, for the first body, Q1 divided by 4 pi r1 square. Instead of r1 square, I am writing r1 into r1 divided by q2 divided by 4 pi r2 square. Again, I am writing r2 into r2. q1 by 4 pi r1 square divided by q2 by 4 pi r2 square. If the two bodies are connected, the potential becomes the same for both. Till then, the charge flows from one to the other. That is, Q1 by R1 equal to Q2 by R2 condition is to be satisfied. Here Q1, 4 pi cancels already. Q1 by R1 is equal to Q2 by R2. Then those two cancel each other. Therefore, finally we have sigma 1 by sigma 2 becomes equal to R2 by R1. Inverse ratio of the radii. Here the radii are in the ratio 1:3. It is given in the question. 10 cm and 30 cm. Radii ratio is 1:3. Therefore, surface charge density becomes 3:1. Inverse ratio of radii ratio equal to 3:1. Now, here the answer is, that is for the surface charge density ratio. Here the answer is 3:1. That is, D choice is the correct answer. The second question is about the capacitance. Electrostatics include field, potential, dipole and capacitance. Capacitance is also a problematic session. Okay, now the second question is about the capacitance. For a parallel plate capacitor or for an ordinary capacitor, the capacitance is given by the expression C equal to epsilon R epsilon naught A by D. That is, C equals epsilon R epsilon naught A by D. For an ordinary capacitor or for a parallel plate capacitor, epsilon R is the dielectric constant. For air, epsilon R is 1. Therefore, if the medium, dielectric medium in between the plates is air, the equation becomes epsilon naught A by D. If the dielectric medium is air, capacitance of the system becomes epsilon naught A by D. That is epsilon R equal to 1. Then epsilon naught A by D. Here the question is, first the medium is air, purely air. Then it becomes epsilon naught A by D. Now, a dielectric medium of dielectric constant 3 is introduced partly, not fully. If the medium is completely introduced in between the plates, epsilon R will have a value 3. Then the capacitance of the system will be 3 times that of the initial. Here, it is partly introduced. Dielectric medium of dielectric constant 3. If we draw the figure, it comes like this. Partly dielectric medium is introduced. Not completely. If it is completely introduced, it becomes 3 times the initial value. Initially, the value is 10 microfarad for the capacitance. And if it is completely introduced, it becomes 30 microfarad because epsilon R becomes 3. Means, if the medium is partly introduced, its value should have an upper limit and a lower limit. Completely filled, the value should be 30. It is completely empty, the value should be 10. Therefore, if the medium is introduced partly, there is a possibility in between 10 microfarad and 30 microfarad. Now, let us have a look about the choices. 10 microfarad, that's wrong, because if the region is air, it becomes 10. Then 45, it is greater than 30, it should not be happened. Then 28 lies in between 10 and 30. Our conclusion is, the result should be in between 10 microfarad and 30 microfarad. And 28 comes in between 10 and 30. Therefore, here the answer. The question is very clear. Have the possibility of becoming the capacitance of the system. Only for C choice, 28 microfarad, which is less than 30 and greater than 10. Therefore, the answer is C. Next question is about the work required in rotating a dipole. The work required in rotating a dipole through an angle theta is given by W equal to PE into 1 minus cos theta, where P is the dipole moment given by P equal to 2L cube. 2L is the length of the dipole, L is the half length of dipole. Two equal and opposite charges separated by a small distance constitute a dipole. The product of the magnitude of one of the charges and the distance between the two gives the dipole moment P here. Here P is the dipole moment and E is the electric field. If a dipole is kept in an electric field, it will have, if kept in a uniform electric field, it will have a tendency to rotate, or a torque is developed. And the work required in rotating the dipole is PE into 1 minus cos theta. Here, in the given question, the dipole is rotated through 180 degree. Therefore, PE into 1 minus cos 180, that is, the expression becomes 1 minus minus 1, or W equal to PE into 1 minus cos pi, means 1 minus minus 1 becomes 2. Therefore, result is 2PE. The work required in rotating a dipole through an angle 180 degree is W equal to 2PE. Here the correct answer is B choice. About the question number 4. It's a theoretical question. Pick out the incorrect choice. Let us read all the choices one by one and have an analysis. The first choice is electric field due to a thin charged sheet is independent of the distance. Actually, it is one of the applications of Gauss's flux theorem. If Gauss's law is applied to a thin charged sheet, the electric field intensity due to the thin charged sheet is E equals sigma by 2 epsilon. Here, distance r is not a factor. Therefore, the electric field due to a thin charged sheet is independent of the distance of the point from the sheet. The first choice is electric field due to a thin charged sheet is independent of the distance. It's a correct choice. But here the question is about the incorrect choice. Second one, the energy that can be transferred from a storage battery to the capacitor will be only 50% of that of the battery. Let us check it. If Q is the charge stored in a storage battery and V is the potential difference or the voltage of the cell, by definition, the energy of the storage battery is QV. Actually, potential is the work required in bringing a unit positive charge from infinity to the present position. That is work by charge equal to V. Therefore, here work equal to QV. Energy of the storage battery having a charge Q and the potential difference across the terminals is V is QV. But for a capacitor, the energy is, we have different expressions. Energy of a charged capacitor is half CV square, one of the equations. Second one, half QV, and the third one is half Q square by C. Three different, they all are same exactly. Then here we need the second equation particularly. Energy of the storage battery is QV. Energy of the capacitor after charging is half QV. That is 50% of the energy of the storage battery can be transferred to the capacitor. That's the meaning. Then the second choice is also correct. Then third one, the energy density due to the electric field in between the plates of a parallel plate capacitor is half epsilon A square. That's also a correct choice. Let us check it. About the C choice. The energy density due to the electric field in between the plates of a parallel plate capacitor is half epsilon A square. First of all, energy density means energy per unit volume. Energy of a capacitor is half CV square. Instead of C, we can write epsilon A by D. Energy density, energy per unit volume, half, instead of C, epsilon A by D. Instead of V, electric field into distance square, divided by energy density, energy per unit volume. Volume of the space in between the two plates means base area into the spacing between the plates. This is the expression for the energy density. A cancels, D and D square cancels, then the remaining term is half epsilon E square. That is the energy density due to an electric field at the electric field region in between the two parallel plates of a capacitor is half epsilon E square. Here, first three choices are correct. Then the question is the incorrect choice. Last one is energy of a capacitor will be greater than that of the voltage source. Already we have proved that only 50% of the energy of the storage battery can be transferred to the capacitor. Here it is given as twice. Therefore, the last choice is wrong. The incorrect choice is D. That is this one. The last choice, energy of a capacitor will be greater than that of the voltage source. It is wrong totally. Therefore, D choice is the answer here. Next question is, electrified soap bubble has a surface tension. There is a relationship between surface tension and surface charge density. In the 11th standard, we have already learned that the excess of pressure inside a soap bubble is delta P equal to 4 into surface tension divided by radius. Excess of pressure inside a soap bubble is 4T by R, where T is the surface tension that is studied in the 11th standard. Now, in the 12th standard, we have another formula for the pressure inside a bubble, sigma square by 2 epsilon. That is, if an electrified soap bubble is taken, it will have a charge. Then sigma is the surface charge density, charge per unit area. Epsilon is the permittivity of the medium. Then by Gauss's law, we have electric field equal to, I'll write it here at the right side. Electric field is equal to sigma by 2 epsilon. Electric field into charge will give the force, normally acting force here. Normal force per unit area. That is force equal to sigma by 2 epsilon into QE. E is sigma by 2 epsilon into Q. Now, normal force by area will give the pressure inside. Then it becomes sigma by 2 epsilon into Q divided by area. This is also charge density. Then it becomes sigma square by 2 epsilon, which is already written here. In terms of the surface charge density, the excess pressure inside an electrified soap bubble is sigma square by 2 epsilon. But in terms of surface tension capital T, the excess of pressure inside the bubble is 4 into surface tension by radius. We have a connection between, we are going to connect these two expressions, that is sigma square by 2 epsilon equal to 4 into surface tension divided by radius. Then sigma equal to 8 epsilon T by R inside the square root. 8 epsilon T divided by capital R inside the root. Therefore, the correct choice is here, the C choice, 8 T epsilon divided by capital R whole inside the square root. C choice is the correct answer. Next question is about a dipole. The electric potential due to a short dipole is 1 by 4 pi epsilon P cos theta by R square. Potential due to a short dipole is 1 by 4 pi epsilon P cos theta divided by R square. Now, relationship between potential and field, minus of dV by dr if R is the variable. In the case of short dipole, at any point around the dipole, we have two choices. One, if R is taken as the variable, minus of dV by dr, that's called radial electric field. That is radial electric field equal to minus of dV by dr equal to minus of d by dr of, instead of b, we'll write 1 by 4 pi epsilon P cos theta divided by R square. This is radial electric field. The question is about the transverse electric field. Of course, there are two types of electric fields here. One, radial electric field, transverse electric field. Then the total electric field will be, net resultant electric field will be the resultant of the two. Transverse electric field is given by minus of 1 by R dV by d theta. Here arc length is taken as the variable r theta. Out of these two, r is a constant, therefore theta becomes the variable. Transverse electric field is minus of 1 by r dV by d theta. Now the resultant electric field at any point around a short dipole is E equal to root of E radial square plus E transverse square. Then we'll get the final result as E equal to 1 by 4 pi epsilon P by R cube root of 1 plus 3 cos square theta. That is the vector sum of E radial and E transverse. Here, the electric field intensity at any point distant r from the center of a short dipole means the resultant electric field due to all types of influences. That is, C choice is the correct answer. 1 by 4 pi epsilon P by R cube root of 1 plus 3 cos square theta. It is obtained like this. First, we have to identify the radial electric field, then transverse electric field, then vector sum of the two. 1 by 4 pi epsilon P by R cube root of 1 plus 3 cos square theta. That is, C choice is the correct answer. Next one is again about the capacitor. First of all, you should know something about the structure of the capacitor. Two parallel metallic plates with an earthing. In between the plates, there is a region, either air or any other insulator called a dielectric medium. Since the region in between the plates is air or any other insulator, it acts as an open circuit to DC. അതായത് വയർ അവിടെ കട്ട് ചെയ്തതിന് ഇക്വലൻ്റ് in between the plates air അല്ലെങ്കിൽ insulator. That is, it acts as capacitor acts as an open circuit to DC. But for AC, DC itself, it acts as an open circuit, but the charge will be distributed over the entire plate. That is, charge storing purpose is carried out with the help of DC. In the case of AC, flow is permitted because alternating current means fluctuating continuously. Therefore, flow of electric signal is permitted for AC. But here the question is, capacitor works on. In the case of DC, it acts as an open circuit, and here the problem is based on this concept. In the given problem, at the middle part, there is a capacitor and a resistor. The capacitor acts as an open circuit because the voltage source is cell DC. DC means electric signal generated because of the chemical reaction. AC means coming from the generator. Here the source is DC. Capacitor acts as an open circuit. Therefore, the current flowing path is only the outermost path. Therefore, the effective resistance, while counting the effective resistance, the resistance given at the middle part need not be counted. Therefore, the loop resistance becomes 5 plus 4 plus 1. Means loop resistance. Middle path is neglected. Only the outer ring is considered. Then loop resistance is 5 plus 4 plus 1. 10 ohm. Then EMF of the source is 10 volt. Therefore, loop current, the circulating current is 1 ampere. Now, the important point is, we have to find the charge of the capacitor. Then, for this, we have to find out the voltage across the capacitor. Voltage across the capacitor at the middle part given in the figure will be equal to voltage across the 5 ohm resistor given at the upper part. That is, 1 ampere current is circulating throughout the loop. 1 ampere current is flowing through the 5 ohm path also. Therefore, the voltage across the 5 ohm resistor, upper 5 ohm resistor is 5 volt. Voltage across the upper 5 ohm resistor will be equal to voltage across the given capacitor. That's also 5 volt. Now, the question is about the charge of the capacitor. Charge Q equals CV. That is 5 volt into capacitance is 3 microfarad. Therefore, 3 microfarad into 5 volt. Therefore, the answer is 15 microcoulomb. Therefore, the answer given in the choices, C choice is the correct answer. The charge of the capacitor at the middle part is 15 microcoulomb. Next one is also a problem about the capacitor. 2 cells are given and 4 capacitors are given. I draw the equivalent diagram of the capacitors. First, 5 microfarad at the leftmost side, then 6 μF and 3 μF in series at the right side part, 6 μF and 3. Instead of 2, I am drawing only one capacitor, 6 and 3 effective values 2 microfarad. Both are in series, 6 into 3 by 6 plus 3. Then another 3 microfarad capacitor parallel to the 2 μF. Now again the equivalent diagram becomes 5 μF and another 5 μF at the right side. Therefore, the effective capacitance of the entire loop is the effective value of 2 5 μF capacitors in series. Effective capacitance is 2.5 microfarad. EMF of the loop is the effective value of 10 volt and 5 volt. The cells are connected in the reverse order. Therefore, the effective value becomes 5 volt, 10 minus 5, 5 volt. Therefore, net charge of the system is CV, Q equal to CV, 5 into 2.5, 12.5 microcoulomb. Now, since the two capacitors are in series, both will have the same charge and the charge of each will be equal to 12.5 microcoulomb. Therefore, here at the right side part, across the 5 μF capacitor, 12.5 microcoulomb. For the 5 μF capacitor, the charge is 12.5 microcoulomb. Then the voltage across this 5 μF is 12.5 divided by 5, 2.5 volt. This 2.5 volt will be appearing across the 3 μF and across the 2 μF since the two are in parallel. Therefore, the charge of the 2 μF capacitor, again Q equal to CV, 2 μF into voltage across 2 μF is 2.5 volt. Therefore, the answer, not the answer, the charge of the 2 μF capacitor is 5 microcoulomb. But the question is charge of the 6 μF capacitor. Here 6 μF and 3 μF are in series. Therefore, the charge of the series combination will be equal to charge of each capacitor included in the series combination, and hence the charge of the 6 μF capacitor will also be equal to 5 microcoulomb. Therefore, the answer is 5 microcoulomb. That is A choice is the correct answer. Next one is a direct question, a simple question about the unit. Practical unit of capacitance. Actually, SI unit of capacitance is farad, but it is a huge unit compared to the practical values of the capacitance. Therefore, practical unit is fixed as microfarad, 10 raised to minus 6 farad. Here the answer is microfarad. C choice is the correct answer. Question number 10. 10th question is the dielectric constant of a metal. Epsilon is the permittivity of the medium, and generally it can be written as epsilon equal to epsilon r, epsilon naught. Epsilon is the permittivity of the medium. Epsilon r is the relative permittivity or dielectric constant. Epsilon naught is the permittivity of vacuum or free space or air. Then epsilon r for air is 1. Similarly, epsilon r for a metal is infinity. You should know these values while doing a problem. Then epsilon r for an insulator greater than 1 but not very high. Here the question is dielectric constant of a metal, that is epsilon r for a metal, it is infinity. Therefore, the correct answer is C. It's a very direct question. Dielectric constant of an insulator. As early mentioned, we have already mentioned in the previous question, epsilon r for a metal is infinity, epsilon r for an insulator greater than 1 but not very high. Here, there is a typing mistake here. Greater than, the correct choice is D, greater than 1 but not very high. You should read this as greater than 1. Then the correct answer is dielectric constant of an insulator is greater than 1 but not very high. Here, next question is, after coalescing several water droplets, what's the potential? First, I will generalize and frame a formula about this question. If there are n identical drops, and if each one is having a charge q, if all the drops are combined or united or coalesced, the total charge of the system becomes nq. But the radius becomes n raised to 1 by 3 r. That is n raised to 1 by 3 times that of the initial value. Now the potential is k q by r, 1 by 4 by epsilon q by r. I am taking it as k q by r. Then q becomes n times. Similarly, radius becomes n raised to 1 by 3 times that of the initial. Then the potential of the system becomes, I will generalize once again. If n identical droplets are coalesced, the total charge of the system becomes nq. Radius of the system becomes n raised to 1 by 3 r. Now the potential of the system, potential is given by the formula kq by r. Now the potential of the system becomes k nq divided by n raised to 1 by 3 r equal to n raised to 2 by 3 times kq by r. That is, potential of the system becomes n raised to 2 by 3 times that of a single drop. An example, suppose 8 drops are combined. N raised to 2 by 3 times means 4 times. Cube root എടുക്കുമ്പോൾ നമുക്ക് 2 കിട്ടുന്നു, square ചെയ്യുമ്പോൾ 4. If 8 drops are combined, potential of the system becomes 4 times that of the initial. Suppose 64 identical drops are combined, cube root എടുക്കുമ്പോൾ 4, square ചെയ്യുമ്പോൾ 16. Then the potential of the system becomes 16 times that of a single drop. Here the question is about the choices about the capacitance and the potential. A liquid drop is having a charge q, similar 125 identical drops are coalesced. Then potential of the system becomes 25 times that of the initial. Similarly, if droplets are combined, radius becomes n raised to 1 by 3 times. Therefore, capacitance will also change if it is taken as a capacitor. Then n raised to 1 by 3 times the initial value will be equal to the capacitance of the system. Here the question is only about the potential. If n identical drops are combined, potential of the system becomes n raised to 2 by 3 times that of a single drop. In the given question, 125 identical drops are combined. Therefore, the result is 25 times as that of the initial. Therefore, the correct answer is the capacitance of the system becomes 5 times that of the, that's correct. Then B choice, the potential becomes 25 times that of a single drop. B is correct, C is correct. Therefore, the correct answer is D. B and C are correct. Once again, I will repeat. If n drops are combined, the potential of the system becomes n raised to 2 by 3 times that of a single drop, and the capacitance becomes n raised to 1 by 3 times that of a single drop. Here 125 drops are combined. Therefore, potential of the system becomes 25 times that of the initial, and the capacitance becomes 5 times that of the initial. Therefore, the correct choice is B and C are correct. D choice is the correct answer. Next question is about the potential of the system. Two spheres are given, radii A and B respectively. B is greater than A, and we have to find the total potential at the center. For this, First, we have to identify the charges of the two spheres. Charge distribution will be proportional to the area. Means 4 pi a square plus b square. That's the total area. Total area is 4 pi a square plus b square. This much of area corresponds to a charge q. The total charge of q coulomb is given. Then, for the outer sphere alone, the charge distribution will be proportional to the area. Outer area is 4 pi b square. 4 pi a square plus b square total area corresponds to a charge q. Then 4 pi b square alone will be this much. This is the charge of the outer sphere alone. Similarly, charge of the inner sphere can also be calculated exactly in the same pattern. Instead of 4 pi b square, it becomes 4 pi a square. Then to find the total potential at this end, we have to add the two potential, algebraic sum of the two. Then the answer comes, this is Q1 and Q2. Then total potential is K Q1 by B plus K Q2 by A. Then for Q1 we will substitute this value. Similarly for Q2 we will substitute Q B square divided by A square plus B square. Then K Q1 by B plus K Q1 by A becomes Q into A plus B divided by 4 pi epsilon A square plus B square. Therefore, here the correct answer is C choice. That is Q into A plus B divided by 4 pi epsilon A square plus B square. Once again, I will explain the whole question. First, we have to identify the charge for each sphere. Charge distribution will be proportional to the area. That is 4 pi a square plus b square. Total area corresponds to a charge q. Then the outer area alone, 4 pi b square, gives the charge of the outer sphere. Similarly, we have to calculate the charge of the inner sphere. Instead of b square, it becomes a square. Then kq1 by r1 plus kq2 by r2. kq1 by b plus kq2 by a. Therefore, the result becomes q by 4 pi epsilon. K is 1 by 4 pi epsilon. Then q by 4 pi epsilon into a plus b divided by a square plus b square. C choice is the correct answer. It's a very good problem, remember. Now we are going to question number 40. It's also a high standard question. A semicircular ring. Total charge of q coulomb is distributed over the semicircular ring. The electric field intensity at the center of curvature of the ring. I will draw the figure. Uniformly distributed q charge. The center of curvature comes here. A small elemental portion I am drawing at the two sides. Total charge is q, therefore charge of the elemental portion becomes dq. Due to this elemental portion, elemental charge, the electric field D comes like this. Similarly, here also a small elemental portion of the charge. The electric field comes like this. Similarly, so many elements can be taken over the entire portion of the semicircular ring. Now, the horizontal components, the two elemental fields will be acting in opposite directions with equal magnitude. Therefore, those two cancel each other. But the vertical components for all the elemental fields will be coming downward exactly like this. If this is taken as theta, this will also be theta. The elemental portion is d theta. Then this will be theta. Here also it will be theta. Therefore, the resultant electric field of all the elemental field will be integral or summation of the vertical component alone, dE cos theta. This is the concept here. Total charge of q coulomb is distributed over the entire ring. Then a small elemental portion is taken. Then charge for that elemental portion is dq. Due to that, elemental charge electric field comes like this. At the other side also one similar element is taken. Elemental field comes like this. For both the elemental fields, the horizontal components are acting in opposite directions with equal magnitude. Those two cancel each other. But for the two, the vertical components are coming in the same direction. Similar, so many elements can be assumed over the entire portion of the semicircular ring. Therefore, the resultant field at the center of curvature will be summation of all the vertical components alone, that is integral dE cos theta. Then dE. Electric field is 1 by 4 pi epsilon q by r square. Therefore, the elemental field dE will be 1 by 4 pi epsilon dq by r square. dq by r square. Now the value of dq. For the length pi r, total charge of q coulomb is given. Therefore, for the small length r d theta, r cancels. Q d theta by pi, that's the value of dq. Here, integral dE cos theta means instead of dE, 1 by 4 pi epsilon q by r square becomes dq by r square. And the value of dq is q d theta by pi 1 by 4 pi epsilon dq by r square instead of d cos theta. Integral of. This is the resultant electric field at the center of curvature. Now the limits of integration. This element can be assumed over the entire length of this ring, that is from the leftmost side to the rightmost side. If the element is taken at the leftmost side, limit becomes minus pi by 2, value of theta becomes minus pi by 2. And if the element is taken at the rightmost side, theta will be plus 1 by 2. Therefore, limits of integration is minus pi by 2 to plus pi by 2. Now, let's have a look at the choice. The electric field due to the entire semicircular ring is q by 4 pi square epsilon r square integral cos theta d theta. I'll write it once again neatly. Q by 4 pi epsilon q by 4 pi epsilon into pi 4 pi squared epsilon q by 4 pi square epsilon r square integral minus pi by 2 to plus pi by 2 cos theta d theta. Q by 4 pi squared epsilon r square integral minus pi by 2 to plus pi by 2 cos theta d theta. The correct answer is A choice. It's a very important problem, and it is purely based on the concept. First, we have to identify the charge of the elemental portion. Then, due to each and every elemental portion, the elemental electric field. Then, summation of all the elemental fields. Finally, q by 4 pi squared epsilon r square integral minus pi by 2 to plus pi by 2 cos theta d theta. On integration, we get this whole thing as 2. Then, actually, the final result comes q by 2 pi squared epsilon r square. Here the answer is A choice. A is the correct answer. Question number 15. It's a theoretical question. Pick out the incorrect one, and all the choices are about the lines of force. First, I will give the definition. What's meant by a line of force? In electrostatics, a line of force is the path followed by an isolated unit positive charge in a region around a stationary electric charge. It has some properties also. Two lines of force never intersect because at a particular position, the field will have only one direction. The two lines never intersect. And if the lines are crowded, the electric field intensity is very high. The tangent drawn to the line of force gives the direction of the electric field, that position where the tangent is drawn. And if the lines are arranged with equal spacing in parallel, that means the field is uniform. Here, let us have a look at the choices. First one is A line of force is the path followed by an isolated unit positive charge. That's actually the definition of a line of force. It's a correct choice. Then, second, two lines never intersect. This is one of the properties. It's also correct. Third one, tangent drawn to the line of force gives the direction of the field. That's also exactly correct. Then, last choice, if lines are parallel with identical spacing, the field is non-uniform. No, the field is uniform. Here we need the incorrect choice. Therefore, the correct answer is D. That is, lines are drawn in parallel, then it should be uniform with identical spacing. Here it is given as identical spacing, field is non-uniform. Therefore, the answer is D. Next question is about the position of stable equilibrium. That is where the net force becomes zero. Here two charges are given, 2 coulomb and 3 coulomb. But second one is minus. 2 coulomb minus 3 coulomb. And we have to identify the point, the position where it becomes in stable equilibrium. That is, the net force becomes zero. Let's take a point to the left of the system. Now, due to the plus 2 coulomb, the force will be repulsive. It comes like this. But due to the minus 3 coulomb, it will be attractive. That is towards the charge minus 3. And to have a condition of stable equilibrium, the net force should be zero. That is, the two forces should have equal magnitude but in opposite directions. Here, directions are already opposite. Therefore, the magnitude should be equal. Let us take this distance from the 2 coulomb to the considering point P as x. Then, the field due to 2 coulomb is 1 by 4 pi epsilon 2 divided by x square, and it is repulsive, that is to the left of 2 coulomb towards the point P. Field due to minus 3 is 1 by 4 pi epsilon, and you should not keep that minus sign here. Sign indicates the direction. 3 by total distances. Distance between the two given charges is along the straight line, and the distance is 1 meter. This is 1 meter. Therefore, the distance of the point P from the second charge is 1 plus x the whole square. These two should have the same magnitude. Direction is already opposite. Therefore, the net force at P becomes zero if the forces are equal and opposite. Therefore, we can equate these two. Solving, we get the result as 2 plus root 6. That is, A choice is the correct answer. To be in stable equilibrium, the two forces should have equal magnitude but in opposite direction. Here, we have to identify the value of x, and it is obtained as 2 plus root 6 meter from the 2 coulomb charge. Therefore, the correct answer is A. Next question is about the electric field. 4 charges are distributed at the 4 corners of a square of side 2 meter. Charges are 2 coulomb, 3 coulomb, again 2 coulomb, 3 coulomb. Actually, to find the resultant field at P, and we have to find the field at P, at the center, diagonal intersecting point. Actually, to find the field at P, we have to identify all the 4 individual fields with the directions and take the vector sum. But here, field due to 2 coulomb is repulsive. Similarly, the field due to the other 2 coulomb is also repulsive. Both the charges are having a magnitude 2 coulomb. Therefore, both the fields will be acting in opposite directions with equal magnitude. Similarly, field due to this 3 coulomb is also repulsive. This one is also repulsive. Therefore, the two fields due to the 3 coulomb charges will also act in opposite directions with equal magnitude. Therefore, we need not draw the vector diagram and find out the resultant field. Here the net field is 0 because fields due to the two Coulomb charges will be cancelling. Similarly, fields due to the 3 Coulomb charges will also be cancelling. Therefore, the net field at P is 0. Here the answer is B. Resultant field at P is 0. Next question is about the potential. Here also, 4 charges are distributed at the 4 corners of a square. 2 Coulomb, minus 3 Coulomb, 4 Coulomb, and 5 Coulomb, 2 meters side of the square. The potential at the central point P here. Potential is a scalar. Therefore, here we have to identify the individual potentials due to each charge, then take the algebraic sum. If 1 by 4 pi epsilon is taken as K, the resultant potential is due to 2 Coulomb, 1 by 4 pi epsilon, 2 by distance is half the diagonal. Side length is 2 meter, then 2 root 2 will be the diagonal, therefore the distance is root 2. 2 root 2 by 2. K 2 by root 2. Then for potential algebraic sum, സൈനോട് കൂടെ തന്നെ നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാം. അപ്പം മൈനസ് 3 by root 2 പ്ലസ് 4 by root 2 പ്ലസ് 5 by root 2. That is minus 1, then plus 3, plus 8. K 8 by root 2. Here the correct choice is K 8 by root 2 volt. Therefore, B choice is the correct answer. Potential is the algebraic sum of the individual potential. Next one is a simple theory question. Pick out the correct statement. First choice is electric potential is a scalar quantity. It's okay. All fields are vectors, but potential is a scalar. Second choice. Electric field is a vector quantity. Electric field, magnetic field, gravitational field, all fields are vectors because all fields are force per unity. Electric field force per unit charge, gravitational field force per unit mass, magnetic field force per unit pole. Therefore, all fields are vectors, but potential is scalar. First choice, potential is a scalar. It's okay. Second one, field is a vector quantity. It is also correct. Third one, electric field is an area around a charge. It is wrong. Field is not expressed in areas unit. It acts, electric field acts over an area or a region around a stationary electric charge. But it is not an area. Unit of electric field is volt per meter or Newton per coulomb because it is not an area. Therefore, here the answer is A and B are correct. First and second choices are correct. Here the answer is D. D choice is the correct. Next one is about the unit of field. First of all, you should know the definition. Electric field acts over a region around a stationary electric charge where an electrostatic force is acting, but it is not an area or a region. Electric field or mathematically electric field intensity is the force experienced by a unit positive charge. Therefore, F by Q or negative gradient of potential minus dV by dr. Therefore, the units of electric field are either volt per meter or Newton per coulomb. Here, the question is SI unit of electric field intensity. First one wrong, joule per second. Second one Newton per coulomb, it is okay. Third one volt per meter, it's also correct. Therefore, the correct choice is B and C are correct. D choice is the correct answer, either Newton per coulomb or volt per meter. Next one is about the dimensional formula of capacitance. If Q is the stored charge in a capacitor, V is the voltage applied across the capacitor, then the ratio Q by V equal to C will be a constant called capacity or capacitance. Therefore, to find the dimension, first we should write the formula Q by V equal to C. For charge, the dimension is current into time. Therefore, Ti. Electric potential, work done in bringing a unit positive charge, work by charge, and we get the result of dimensional formula of V as ml square T minus 3 I raised to minus 1. ml square T raised to minus 3 I raised to minus 1 is the dimensional formula of V. Solving, we get m raised to minus 1, L raised to minus 2, T raised to 4 and I raised to 2. For current, we can take I or A. Therefore, the answer is m raised to minus 1, L raised to minus 2, T raised to 4, I raised to 2. M raised to minus 1, L raised to minus 2, T raised to 4, I raised to 2. A choice is the correct answer. Next one is about capacitor. നേരത്തെ നമ്മൾ മെൻഷൻ ചെയ്തൊരു കാര്യമാണ് in between the plates of a capacitor air or any other insulator is filled or it acts as the dielectric air or any other insulator will be acting as the dielectric medium. Therefore, to a DC voltage source, capacitor acts as an open circuit but charge storing purpose is carried out. In the case of AC, the signal flow is permitted. Thus, a capacitor works on both AC and DC, but different role to AC and DC. Here the answer is capacitor works on both AC and DC. C choice is the correct answer. Next one is, pick out the correct choice. V potential, E electric field. Those symbols are given. First choice is minus dV by dr equal to E. That's the basic definition of electric field. Negative gradient of potential gives the electric field and hence it has the unit volt per meter. A choice is the correct answer. Then second one, dimensional formula of electric field is force experienced by a unit positive charge. That is formula is F by Q. For F, the dimensional formula is mL T raised to minus 2. For charge, the dimensional formula is Ti. Therefore, for electric field, mL T raised to minus 3, I raised to minus 1. This is the dimensional formula of electric field. Here, in the second choice, the dimensional formula of electric field is mL square T raised to minus 3, I raised to minus 1. That's also correct. Then third choice, electric field is a vector quantity. It's also correct. Therefore, here the answer is A, B and C are correct. All the three choices are correct. Therefore, the correct choice is D. Next question is about the potential. Inside and on the surface of a uniformly charged hollow conductor, the potential remains the same throughout, but the field will be zero because electric field is negative gradient of potential minus dV by dr equal to field. Here, the potential is constant, therefore minus dV constant on differentiation gives 0. Electric field intensity will be 0. Here the question is based on this concept. Two spheres are given. Radii R1 and R2, R1 greater, for the outer one R1, for the inner one R2. Now the question is, the potential at the point distant R from the center in between the two spheres. Here a point is taken at a distance R from the center. We have already mentioned, inside and on the surface of a uniformly charged hollow conductor, the potential remains the same. Therefore, if the potential at the surface is V, it remains throughout at any point inside. Therefore, as far as the outer sphere is concerned, P is an inner point. Therefore, potential due to the outer sphere is 1 by 4 pi epsilon Q1 by R1. It's surface potential. But as far as the inner sphere is concerned, the point P is an outer point. It is at some distance away from the surface also. Therefore, potential at P due to the inner sphere alone is 1 by 4 pi epsilon Q2 is the charge of the inner sphere, but we have to consider the total distance up to the considering point because it's an outer point as far as the inner one is concerned. Q2 by R. Therefore, the total potential at the point is 1 by 4 pi epsilon common to both Q1 by R1 plus Q2 by small r. Since the point P is at the inner part of the outer sphere, we have to take the surface potential. And at the outer part of the inner sphere, total distance we have to consider. Therefore, the total potential is 1 by 4 pi epsilon Q1 by R1 plus Q2 by small r. Therefore, here the correct answer is 1 by 4 pi epsilon Q1 by capital R1 plus Q2 by small r. Second choice, B choice is the correct answer. Here, several charges are distributed along a straight line at distances 1 meter, 2 meter, 4 meter, etc. We have to find the field and potential at the point x equal to 0. Several charges. Now, this is the point x equals 0. Then at 1 meter distance, 2 meter distance, 4 meter distance, a charge q coulomb is distributed, etc. Continuously going on. It's going on. Then the potential, first we will do the potential at the point x equal to 0 here. We have to take the individual potential due to each and every charge, then take the algebraic sum. I will take the 1 by 4 pi epsilon as k. K, q, due to the first charge the potential is kq by 1. Due to the second one, kq by 2, 1 by 2. Third one, kq by 4 plus etc. Now, it's an infinite GP. Sum to infinity of a geometric progression is a by 1 minus r. Therefore, here the result is kq into a by 1 minus r, 1 by 1 minus half, half, then 2, then answer is 2kq, where k is 1 by 4 pi epsilon. This is the potential at the point x equal to 0. Now to find the field, kq by r square, same pattern. For the field, kq by, first one, 1 meter distance, q by 1 square plus kq by 2 square plus kq by 4 square plus etc. It's also an infinite GP. K, q, a by 1 minus r, 1 by 1 minus 1 by 4. Now it becomes 1 minus 1 by 4, 3 by 4, then 4 by 3 kq is the electric field at that point. K is 1 by 4 pi epsilon. We substitute the value of k as 1 by 4 pi epsilon. Then the potential and field. First the electric field, second one potential. Then the correct choice is q by 3 pi epsilon and q by 2 pi epsilon. That is B choice is the correct answer. Substituting the value of k equal to 1 by 4 pi epsilon. That is q by 3 pi. Then here 4 by 3 kq. K is 1 by 4 pi epsilon. 4 cancels. Then the correct answer is B choice. Q by 3 pi epsilon and q by 2 pi epsilon. This is the last question in this question paper. Electrostatics is an important, huge topic actually, containing 4 smaller units: electric field, potential, dipole, and capacitance. All are highly problematic sections. Therefore, you have to go through the theory first, then go through these 25 questions, then yourself you practice taking pen and paper. ഇത്രയൊക്കെ ചെയ്ത് കഴിഞ്ഞാൽ നിങ്ങളുടെ തലയിൽ ഇത് റെക്കോർഡായിട്ട് അങ്ങ് സ്റ്റോർ ചെയ്തിരിക്കും. പ്രോബ്ലമാറ്റിക് ടോപ്പിക്കാണ്. പേപ്പറും പെന്നും എടുത്ത് ഒരു ടെസ്റ്റ് പേപ്പർ പോലെ ഈ ഡിസ്കഷന് ശേഷം 1 to 25 ക്വസ്റ്റ്യൻസ് ഒന്ന് പ്രാക്ടീസ് ചെയ്ത് നോക്കുക. അപ്പോൾ അത് എല്ലാം യൂസ്ഫുൾ ക്വസ്റ്റ്യൻസ് ആണ്. തിയറി പ്രോബ്ലം എല്ലാം അതിലുണ്ട്. ഇത് പെർമനൻ്റായിട്ട് തലയിൽ റെക്കോർഡ് ചെയ്തിരിക്കണമെങ്കിൽ ഇത്രയൊക്കെ ചെയ്യുക. ഇത് എല്ലാ പ്രോബ്ലംസും പരീക്ഷയ്ക്ക് വരാൻ നല്ല സാധ്യതയുള്ള ചോദ്യങ്ങളാണ്. പ്രത്യേകിച്ച് ഇപ്പോൾ ബോർഡ് എക്സാംസിന് പ്രോബ്ലത്തിന് കൂടുതൽ ഇമ്പോർട്ടൻസ് ഉണ്ട്. അപ്പോൾ അതിൻ്റേതായ സെൻസിലെടുത്തിട്ട് ഒരു 1 hour അല്ലെങ്കിൽ 1.5 hour ഒരു പേപ്പറും പെന്നും എടുത്ത് ഈ 25 ക്വസ്റ്റ്യൻസ് സെൽഫായിട്ട് പ്രാക്ടീസ് ചെയ്യാൻ നോക്കുക. വിഷ് യു ഓൾ ദി ബെസ്റ്റ്. താങ്ക് യു.